Hi everyone, so in this video we're going to be talking about future value. So future value is going to be a little bit different than the compound interest that we've already talked about. There is still going to be interest in it, it's just going to be a different formula and a little different way of thinking about it. Okay, so first off, we're going to talk about annuities. So an annuity is, so if I get the right pen, is a series of equal periodic payments. So what I mean by that is if you put $200 into an account every month for retirement, it's every month and it's $200 each of those months. That's an annuity. Now, there's two different types. There's annuity due and ordinary annuity. For this class, we're just going to be working with ordinary annuity. So ordinary annuity just means that the payment is at the end of the period. Annuity due would mean that it's due at the beginning of the period, but for this class, we're just going to be talking about ordinary annuity. Now, future value is the final accumulated sum of all payments plus interest. Right, so it's similar to compound interest in that every, say, month, it's going to be accumulating more interest. The difference here is that you're also going to be adding more to the account as well. So the payment is the big difference. So the big clue that you are going to be using future value instead of just normal compound interest is if anything has a payment. So if you are putting $200 into an account every single month, that's a payment, that's future value. Rather than regular compound interest, which is just, I'm going to put in $200, I'm never going to put anything else in there again, I'm just going to let it sit there and grow. That's regular compound interest. All right, so formulas. Now, one big note for these formulas is this is not going to be the same N that we used in compound interest. The N has a different meaning here, and I'll get to that in a second. So we have FV, which stands for future value, which again is that total accumulated amount after a certain number of payments. PMT is the amount of each payment. N is actually the total number of payments. So instead of it just being the number of compoundings per year, it's actually the number of compoundings per year times the number of years to get the total number of payments. And then we have I, which is the rate as a decimal divided by the number of compoundings per year. All right, then we're going to have three equations for this. Now, these are all the exact same equation. I just already solved for certain things for you. Okay, so this is the main one. For future value, this is the equation you use to actually solve for future value. If you want to solve it for anything else, you have to actually solve for that variable. Now, PMT is not actually too difficult to solve for. All you would do if you want to solve for PMT is divide by all of this stuff. So if we divide by all of that stuff, we get this equation. Now again, the work's already done for you here, so anytime you're looking for the payment, use this one. It's already solved for. Now the little bit trickier one to solve is solving for n, that total number of payments. So, at least for now, I'm just going to ask y'all to trust me that this is the formula. All right, if you want to try solving for n, you can, but it's a little bit more involved with the logs than we've got into in this class. So just trust me that this is already solved for n. So anytime you're looking for the number of payments, this is the one you want to use. And luckily, what that means is that since you have 3 different formulas depending on what you're solving for, you're never going to actually have to solve for anything. You're just plugging stuff in. Now, that said, these are kind of nasty, so let's practice plugging stuff in first. So let's look at example 1. So find FV if the payment is 500, I is 0.03, and N is 60. Okay, so we're looking for FV, which means we're going to use this first one. So all we're going to do is plug those numbers into their correct spots. So we have FV equals PMT, which is 500, and then 1 plus I, which is 0.03, raised to the N, which is 60, minus 1, all over I, which is 0.03. Luckily, at this point, you get to just plug this straight into your calculator. Right? Now, one general tip, if you have an older calculator that you can't just plug it in all at once, the order that you're going to want to plug this in is start with this. Once you plug that in, subtract 1 from the answer. Once you have that, divide it by 0.03. And then once you have that, finally multiply it by the 500, and that'll get it all plugged in for you. If you have like a TI-83 or a TI-84, then you'll be able to just plug this all in at once. Alright, so with that said, if we do go ahead and plug all of this in, we should be getting about $81,526.72 if we round it to the nearest cent. All right, let's try another one. Find PMT if FV equals $20,961.21, I is 0.0025, and N is 120. Okay, so for this one, we're solving for PMT. So that means we're going to use this second equation. All right, so if we go ahead and use that second equation, we have PMT equals FV, which is 20,961.21, I on top, so 0.0025, over 1 plus I, so 1 plus 0.0025, raised to the N, which is 120, minus 1. Again, just like FV, If you're doing this on an older calculator, what I would recommend is doing it kind of in the same order. Get the bottom first, then take 0.0025 divided by that answer, and then multiply it by the 20,961 at the very end. If you have a TI-83 or 84 or any other kind of graphing calculator, you can plug all of it in at once and you're good to go. All right, so if we plug this in, we should be getting 149.99999. But if we want to round it up to the nearest decimal, or sorry, the nearest cent, then this would round up to $150. All right, let's try one more. So for this last one, we're going to find N. If FV equals 1,979.36, the payment's 82, and I is 0.0005. All right, so this time we are solving for N. So we're going to use this last equation right here. All right, so if we go ahead and plug everything in, we have N equals natural log of FV 1,979.36 over the payment, which is 82, times I, which is 0.0005, plus 1 all over the natural log of 1 plus I, so again 0.0005. Again, plug all of this into your calculator. If we plug all of it into our calculator, then in this case we're going to get 24, and that's rounded to 2 decimal places as well. All right, so hopefully you can see how we plug these numbers in. So now the trick is going to be taking a word problem, finding these different values, and then from there it's plugging it in just like we did here. So that's what we're going to do next. We're going to go ahead and look at some word problems, try to get these pieces of information, that way it becomes just plugging it in again. So let's start off with one that we're going to be solving for future value. So Amy starts a savings account. She puts $200 each month into an account earning 1.2, and sorry, that is supposed to be 1.2%, that was a typo, interest compounded monthly. How much will she have in the account in 10 years? Okay, so for all of these, I'm going to write down those 4 different variables that we need. So we need FV, we need PMT, N, and I. All right, so let's go through these one at a time. FV is going to be the final amount at the end. Right? Now, in this case, we don't know because we're asking how much she will have in the account at the end of the 10 years. So that's what we're going to be solving for. Next is PMT, that's the payment. It says she puts $200 each month. That's the payment part. Every single month, she's putting $200. So our payment will be $200. Next is N. N is the number of compoundings per year times the number of years. So it's compounded monthly, that's 12 times a year, over 10 years. So that's times 10. So N is going to be 120. Lastly, we have I. So I is the rate as a decimal divided by the number of compoundings per year. All right, so 1.2% would be 0.012 as a decimal. So it's 0.012 divided by, again, it was compounded monthly, so divided by 12. Now, as long as you can actually divide it and it gives you a nice number, you can go ahead and do that. If it gives you a nasty repeating number, then I would suggest leaving that part as a fraction. But in this case, if we do 0.012 divided by 12, we get 0.001. And that's a perfectly nice number, so we'll use that whenever we are actually plugging this stuff in. With that said, we are going to go ahead and plug it in now. So we're solving for FV, so the formula we're going to use is FV equals PMT, and on the top we have 1 plus I to the nth minus 1 all over I. So let's go ahead and start plugging stuff in. PMT is 200. Then 1 plus 0.001 is I. N is 120. Minus 1 all over I again, so 0.001. And then it's just a matter of putting this into your calculator again. Don't forget we do round it to the nearest cent. So if we go ahead and plug it in, we're going to get approximately $25,485.85. And that is the answer to our question. The future value of that account is $25,485.85. All right. Now, that doesn't necessarily mean that Amy actually earned that much, because remember, she put $200 each month herself. So, just as a little side note, if we did want to find out how much she actually earned, so how much interest she made on it, all we would have to do is take the amount that she paid, multiply it by our N, so the number of payments, which was 120. So if we multiply 200 times 120, we should get 24,000. Now, to get the actual interest, that's going to equal the future value minus this that we just got. So it's minus the payments times the number of payments. All right, so that would be 25,485.85 minus the 24,000 equals $1,485.85. So that's how much she actually earned on that account. $24,000 of what was in that account was actually her own money, right, that she's been putting in over those 10 years. But $1,485 of it is what she actually earned on top of that to get her up to that $25,485. All right, let's go ahead and take a look at another one. So example 5. Sobia's business wants to expand in Rachel's business wants to expand in 5 years. She needs $100,000 for the expansion. So he starts to save now. I'm sorry, these should all be she. I changed the name, but I did not change that. I will fix it before I give you all the notes. All right, so she needs $100,000 for the expansion, so she starts to save now. How much should she put each quarter into an account earning 3.6% interest compounded quarterly to be able to get the money in time? Okay, so first thing that we're going to do is, again, we are going to go ahead and write out all of our different variables. So FV, PMT, NI. All 4 of those are going to be written out every single time. All right, so FV is how much is going to be in there at the end. All right. In this case, we know how much she wants at the end. At the end, she wants $100,000. All right. Payment. That's the part we don't know. Because we're trying to figure out how much should she put each quarter into an account earning that percentage. So we're going to be solving for that. N is number of compoundings per year times the number of years. So it's going to be per quarter, which is 4 times a year, for 5 years. So that's 20. And I is going to be the rate, again, as a decimal. So make sure that we're going to write this as 0.036. And then we divide it, again, by the number of compoundings per year. So 0.036 divided by 4, it's going to give us 0.009. All right, we are looking for payment. So let's go ahead and write down that formula. Payment equals FV, then I over 1 plus I to the nth minus 1. And let's start plugging in everything. So FV is 100,000. I is 0.009. Then 1 plus I, so 1 plus 0.009 to the 20th minus 1. And again, we're going to plug all of this into our calculator. So if we go ahead and plug all of that in, we get $4,585.90 if we round it to the nearest cent. All right, so in order to get $100,000 over those 5 years, that's the payment she'd have to put in each quarter in order to get there. All right, let's look at one more. Sobia is saving up for a new computer. The one she wants is $2,000. She can afford to put $10 a month into an account earning 4.2% compounded monthly. How long will it take her to get enough money for the computer? All right, so for this one, we're going to start off once again FV PMT in I. So if she wants a $2,000 computer, that is going to be the future value, because that's how much that she's going to need after however long, because we don't know that part yet. The payment, she can afford to put $10 a month. So it's $10 for a payment. N is the number of compoundings per month times, the number of compoundings per year times the number of years. Now, in this case, we don't know how many years. We know that's 12 compoundings per year, but we don't know the number of years, so we don't know N. And then I is going to be the 4.2 as a decimal, so 0.042, divided by number of compoundings per year, so that's 12. All right, and again, plug this into your calculator. As long as it is a nice number, then use that nice number. It makes your life easier. In this case, it is a nice number, so 0.0035. All right, we're trying to solve for N. So if we go ahead and look at that formula, is N equals natural log of FV over PMT times I plus 1, all of that on top, the natural log of 1 plus I on bottom. All right, let's go ahead and start plugging stuff in. So on top, we got natural log of 2,000 over 10 times 0.0035 plus 1 over the natural log of 1 plus I. Sorry, 1 plus 0.0035. Then we can go ahead and plug all of that into our calculator. All right, so if we plug this into our calculator, we get approximately 151.87, and that's the number of payments, remember. All right, now we can't have a fractional payment, so we're going to go ahead and round this up to 152 payments. Now remember, the payments in this case were per month. So 152 months is how long it would take to actually build up enough to be able to buy that $2,000 computer. Right? Now, depending on the problem, it might ask for it in years. Keep in mind, if it does, all you gotta do is divide that by 12, and you would get approximately 12.67 years. Just make sure you pay attention to what unit the problem wants. Most of them will be fine with you just leaving it in months, though. All right, and with that said, that is all for the future value section. So keep in mind, biggest thing is being able to just take out all of these different variables from the word problem. And once you have those variables, plug it into the correct equation, depending on which one you are solving for. And then it's just plugging into your calculator from there. Let your calculator do the majority of the work. And with that said, that is the end for these notes. In the next ones, we are going to talk about something very similar. The problems are going to look extremely close to one another, but instead of savings, it's going to have more to do with loans. So I will see you in the next video. Thank you.